We're going to go through just a couple of concept questions. Just a couple of them specifically looking at the magnetic field. So capital B is the symbol we're using for magnetic field. Due to a moving charge. Try answering the question on your own first, and then watch the solution as well. So here is our first question. The correct answer here is C. We can do this quickly if we want in terms of right-hand rule. If we put our thumb of our right hand in the direction of the velocity. So take your right hand, orient it so that you have your thumb pointing towards the top of the screen. So your hand should be oriented where you have your thumb pointed that way up, and your fingers just relax. Your fingers are going to be looping around kind of like this. And I apologize, I'm not the best artist. Okay, so these are your fingertips. This is your thumb. Magnetic field is circles around a charge. So our fingertips are representing which way these circles around the charge would point. Point P is to the left. It's also down, I know, but it's to the left of the charge. So tangent to the circle right here would be exactly out of the screen. If you held your fingertips, the tips of your fingers, as close as you could, aligned with your thumb in terms of being in the same plane. Your fingertips directly to the left of your thumb are pointing towards you. And that's what we mean by this, out of the screen. It points towards you. Now, granted, the point we care about is down here. This has an X component and a Y component. But if you recall, to find the magnetic field due to a point charge requires solving a cross product equation. When we're taking and solving the cross product only multiplies components that are perpendicular to each other. So all we care about is that it has an X component. Since the Y component is parallel to V, as far as direction is concerned, there will be no magnetic field due to the Y component. Okay. R hat would have an X component and a Y component, an I hat and a J hat component. In this particular example, it's only the X component that's going to give us a non-zero answer. The Y component will end up giving us a zero answer if we take J crossed with J. That gives us 0. So right-hand rule, thumb in the direction of the current. Fingertips show which way around the current. Thumb in the direction of the charge moving. The fingertips show you which way around the charge. So just one other thing that might be helpful is to change my viewpoint. Let's say the charge is moving towards me. Out of the screen. So the velocity would be a dot pointing towards me. If I put my thumb in the direction of velocity, so I point my thumb at myself, point my thumb at my face, my fingertips point this way, counterclockwise in general. What that means, I better draw that better, is that the magnetic field around this charge is going counterclockwise from this viewpoint. There would be concentric circles representing magnetic field. The point we are interested in is to the left of the charge. So tangent to the circle at exactly this location in this viewpoint would be down. But now take your hand. So you have your thumb of your right hand, so the right thumb pointing at you, so pointing at your face. Your fingertips, if they were little arrows, are pointing counterclockwise. Now just rotate your wrist keeping your same hand orientation, so your thumb points up. And that will now represent this view on the left side, so up here. So it does depend totally on from what angle we're viewing the magnetic field in our hand. But in general, we get these nice little circles, circle of magnetic field, and our right hand can tell us what direction those circles are going. Oh, I gotta go get the next question. All right, one more question. All right, correct answer here is C. Right hand rule again. I need to point my thumb of my right hand away from me, into the screen. So into the screen, the direction of this velocity. It's a little awkward to try to point your thumb away from you, but do your best. When I do that, my fingertips are pointing this way. What that means is that the magnetic field lines are making circles that are going clockwise around this charge from this perspective. So this point over here, if I draw a big old circle, clockwise in general, but the question is asking specifically about this point. I can't say clockwise. There's no such thing as clockwise at one single point. The direction of the magnetic field is always tangent to this circle at this location. So tangent to the circle at exactly that dot would be up towards the top of the screen. And so that's why this magnetic field points up, because that's the direction that's tangent. If we wanted the magnetic field at a point up here at the top, it would point to the right at that location, because that is what's tangent to that circle. Okay. Now, one other thing, just as a side note, when we are trying to find the magnetic field, our charges could be negative, right? That could be an electron instead of a proton. If Q is negative, we simply get a direction that's opposite what we get for the positive charge. What that means is if we had an electron with V into the screen, we just drew these circles going clockwise. If the charge was negative, it would just mean the opposite, so counterclockwise. So something to keep in mind is just opposite the positive charges. All right, I decided on one last question. So one more. Correct answer is A. Now, I know we've been talking about charges specifically, but as a reminder, the traditional definition of current is the flow of positive charges. So, a positive charge moving to the right, if I put my thumb and point it to the right, my fingertips up here will point out at me. So the circles for the magnetic field are coming out on this side, going in on the back side. And so at that exact point at the top would be tangent to the circle, would be straight out towards me. So this is what we're going to talk about next, is the magnetic field due to a current carrying wire. A straight wire, and then we'll look at a couple other situations as well.